Okay, in this video we're going to see how to find confidence intervals using the TI-83 or 84 calculator. Consider this problem. A manufacturer claims that their batteries have a mean lifespan of 400 hours with a standard deviation of 40 hours. You collect a sample of 30 batteries and calculate the mean to be 380 hours from your sample. Find the 95% confidence interval for the population mean. So we want to find a 95% confidence interval for the population mean. To find confidence intervals, to do hypothesis tests and so on the calculator, you have to click Stat. So click on Stat and scroll across to Tests. Then you have to decide, what am I going to do? We want a confidence interval, and we're going to have a Z interval because even though it doesn't say anything about normal distribution, the central limit theorem tells us if my sample is greater than 30 and I know the population standard deviation is 40, I can assume a normal distribution. So what we're looking for is a Z interval. So we click enter, and there are two things here. You have data if you had a list of data, but we have statistics, we have some numbers. So we click enter on stats, scroll down to the standard deviation. The standard deviation is given in our problem as 40. So we know the standard deviation is 40. That's the population standard deviation. The mean of our sample is 380. The sample size is given as 30, and the confidence level is 0.95 or 95%. So we calculate this. When we calculate it, we get our Z interval of 365.69 to 394.31. Just note, if we want to get the error is going to be equal to 365.69 minus 394.31 and the absolute value of that. So you take the absolute value of the difference between these two and you divide by 2, and so you will get the error as 14.31. So the error is 14.31, but the confidence interval is 365.69 to 394.31. Now let's change this problem slightly. How would I change this slightly? Well, let's say we don't know. Let's say the population standard deviation. We don't know the population standard deviation. How does that change this? Okay, now we're looking at a manufacturer claims that their batteries have a mean lifespan of 400. You collect a sample of 30 batteries and calculate the mean of the sample to be 380 hours. In addition, the standard deviation of the sample is 40. So we're no longer talking about a population standard deviation. We have a sample standard deviation of 40. Find a 95% confidence interval for the mean. So if you had a sample, you would certainly be able to calculate the standard deviation. And this is a more realistic scenario where you have the sample mean, you have the sample standard deviation, and you have no idea about what's going on in the population. And we'll talk about this claim in a minute. So, what do I do to find the 95% confidence interval? We have to recognize this is a T interval. And we have 30 in our sample. That means we have degrees of freedom of 29. So to find a T interval, we click Stat, go across to Test again, but instead of Z interval, we look for T interval, one below that. You click Enter, and here we'll click Enter on Stats, and the mean is 380 like we had before, but the standard deviation is SX. Notice SX, that's for the population, for the sample, sorry, and that's going to be 40. And the sample size is 30, confidence level is 0.95, and so we calculate that. And notice we get 365.06 to 394.94. So if you might notice that this interval is a little bit wider than the previous interval. And that's because it's a T interval And if you calculate the error for this one is 14.94. How did we get the error? We take the maximum minus min, the two bounds here, take the difference and divide by 2. So my error is a little bit higher there because in a t-interval we're making an assumption about this standard deviation from the sample, and so it's a little bit wider interval on a t. But regardless, notice in the previous interval and this t-interval that 400 was not in that interval. We go from 365 to 394, and what that's telling me that I'm 95% confident that the true mean is in here somewhere and that 400 is not there. So we have reasonable doubt, we have reason to believe that the claim of 400 may be slightly high. Now let's look at finding a confidence interval for a proportion. So far we've talked about means. How do we do that for a proportion? Okay, so in this question we are told that to determine the results of an election, a pollster surveys 100 people and asks them who they will vote for. We're assuming a random sample that they collect. And of the 100 people, 60 say they will vote for candidate A. So that means there's a 60% proportion that we got from our survey. However, rather than do a point estimate, we prefer to do a confidence interval. So the question is asking it to calculate a 99% confidence interval for the population proportion that will vote for candidate A. So how do we do this on the calculator? We click Stat again, go scroll across the tests. But in this case now, we want a 1 proportion interval. So we scroll down all the way to A, and it's a Z interval because what we're doing is we're using the binomial approximation, or the normal approximation of the binomial distribution and the central limit theorem. So that's combined to give us a 1 proportion Z interval. That's what we're calculating. So click on that, and what you have to enter here is X is the number of successes. In this case, X is the number of people who will vote for candidate A, which is 60. N is my sample size, which is 100. So notice 60 out of 100, that's 0.6 was my proportion. My confidence level is 0.99 in this case. And we click calculate, and there is my proportion. So my proportion is going from 0.473 to 0.729. So it's quite a wide interval, 0.72619 to 0.47381. And if you take the difference between those two numbers and divide by 2, you find your error is equal to approximately 0.126. In other words, my error is about 12%, 12 points, 13 points. And the reason the error is so high is because we're very confident. So the more confident you are, the wider that interval becomes, the more error there is going to be. So my error is high. So if I wanted to reduce the error, I'd have to say this with less confidence. In other words, if I wanted 95% confidence, if I redid this entire calculation, so we go Stat, Tests, we're all the way down to 1 proportion Z interval, and the same 60 and 100, but instead of C level 0.99 I put 0.95. You notice the confidence interval is reduced, and it's about now from 50% to 69%, 70%. My error would be reduced to approximately 10%. So if you say something with less confidence, you're going to have less error in that calculation. So that's how you get a confidence interval for proportion using the calculator.